Let's talk about integrating products of powers of tan x and secant x. So the general expression will look like this, and you could see here if n is even and positive and m is any real number, the strategy here is to split off a secant squared and rewrite the remaining even power of secant x in terms of tan x, okay, and then use u substitution. On the other hand, if m is odd and positive and n is real, then the strategy is to split off a secant x tan x and rewrite the remaining power of even power of tan x in terms of secant x, and using the u substitution there. And finally, if m is even and positive and n is odd and positive, then the strategy is to rewrite even powers of tan x in terms of secant x to produce some polynomial in secant x, and then apply the reduction formulas that we've seen before, or use other methods to simplify the expression. So the trig identity that's relevant here is secant squared x minus tan squared x is equal to 1. Okay, and so let's take a look at a concrete example. So we have tan cubed secant to the fourth. Where does that fit? Well, the tan is cubed, so we could say m odd and positive. That's true, and 4 is a real number, so we could use this strategy here. On the other hand, 4 is even and positive, and 3 is real. So we could use either one of these, and in fact, let's take a look at both. So let's start with the n even and positive strategy and split off a secant squared x. So what we'll do here, we have a secant to the fourth. We're going to split off a secant squared x, and we have this term remaining over here. We're going to rewrite the remaining even power of secant x in terms of tan x. And how do we do that? Well, we use this trig identity. And so we write the remaining even power in terms of tan. So secant squared is 1 plus tan squared x. And we then do the u substitution with tan x. And du is secant squared x dx. And so you get this expression here, which you could easily integrate with the power rule, substitute back the expression for u, which was tan x, and you get this result. Now, what if on the other hand we chose to use the second strategy, m odd and positive? Here we'll split off a secant x tan x. Okay, and here you'll see the alternative solution. So to split off a secant x tan x, we're left with that power. What do we do after that? Well, we write the remaining even power of tan x in terms of secant x. Okay, and so we have a tan squared. We're going to write it in terms of secant x using the trig identity above there. And we're going to choose u substitution with u is equal to secant x du secant x tan x. Okay, and doing so, we can rewrite the integrand in terms of u this way, integrate again, and we get this result. Now, these might look different, but they're in fact the same. If you use the trig identity 1 plus tan squared x secant x, and you plug that into here, you'll get a similar expression there. And so they are equal. And so we saw how both of these strategies here would work. And you could see a similar idea pervading the integrating of powers of sine and cosine and integrating powers of tan and secant. The idea is always, to split off a term such that you could sweep off that split off term into the du and to rewrite the remaining expression in terms of u. That's the sort of pervading theme in all of these problems that we've looked at. So that's what's going on. And, if you want particular strategies, then, you could fit them into the boxes that we looked at before, but it's important to understand the general theme as well.